So I've got a rectangle. I've kind of drawn it out here. Set my origin, and then A, B, and C. And O to A is 8, and A to B is 6. And I've drawn it really well to scale. And so we can do, just based on those two vectors that were given, we can say that we know what A to C is, that diagonal, and what O to B is. And if we think about what our actual vectors are as far as position vectors, since we know the length of O to A is 8, that would tell us that that vector would be 0, 8. And since A to B is 6, that means O to C is 6. And so you would know what that vector is as well. And so putting those together, O to B is A plus B as far as the vectors go. But we also know what the coordinates of that point B is, because we could just add our two vectors together and we get 6, 8. Now in 2 dimensions, this seems pretty straightforward. You can see the power of this when you're working in 3 dimensions. You can really put a lot of vectors together. Okay? So now, part B. What is the length of O to B? Well, since we figured out that our vector was 6, 8, we can just figure out its length by doing, oops, I miss it there. Scroll down. There it is. Length of O to B, just the 6 squared plus the 8 squared. And its length is 10. It's a nice 3, 4, 5 triangle happening. I'll let you try part C, and I'll put the answer up in a bit. So we have our first O to B, and since we figured out A to C, C to A would just be the negative. And we already know that the length of A is 8. So we get that the length is 16. If we go back to our diagram here, what's actually happening when we add O to B and then C to A? We get exactly 2 lengths of A. And the very last one there, O to A, A to C, C to O. Uh-oh. And we get a 0 vector because you ended up the same place.